Now we're going to study level curves. Okay, and let me just say indifference curves are level curves. Nobody told you in first sem this language. Okay, what were you told? You have this, you have good x1 here, x2 here, or x and y here, and you have the level of utility constant along indifference curve, and if they are both goods, then utility increases in this direction. Okay, now you should now, after this class, know exactly what this means. Did you not wonder at that time, what is this? Why we just memorized? That's what first semester students are made to do. They're just made to memorize that this is so. Okay, Z. If you have this, okay, this is again minus of z is equal to minus of x square plus z square, but the origin is not here. Origin is here. If on top of this, if I do something like this that I just did, z is equal to c. If I draw that plane, how would that look like? Okay, all along this z is equal to c, and just to make a little, all right. Now what this shape is, it's hollow in between. It's in 3D. I'm going to, okay, this makes it a little better in appearance. It's hollow in between. It's something like this. This is a cap. It's like this. It's hollow in between. Okay. Now I'm going to this. Now keep that in mind. That is hollow in between. So what I do, if I just cut it in half, let's say this is a big blade. If I just cut it in half, you'll have a border. Alright? And all along that border, z value would be constant. Z value is what? It's height of this. Okay, across that, those ordered pairs x and y, they would change, but the z value would remain constant. Now, if I just twist it around, if you're looking from top, then you would not have any sense of the height. Okay. Let's say this plane is cutting this inverted paraboloid, and you would have a image like this in 2D. If I just cut it, and this ring, if you see it from above, it's going to look something like this. Okay, how would this look like in 2D? X, y, it's going to look something like this. Okay, these are level curves. Okay, level curve for z is equal to c. The third dimension is not shown here, it's in the background. The value of that dimension is same all across this. Alright, if I say that this is a utility hill, that good one, good to, and the level of utility. So to begin with, you start consuming more of one, more, and your utility is measured here, it increases till the time your marginal utility is positive. Increasing this is going to increase utility, beyond a point is going to decrease it. Okay. In two dimensions, this is your indifference curve, it's a level curve. Okay, till the time it's convex and downward sloping, what do we have? You have positive marginal utilities. So increasing one, you have to decrease other, so that level of utility remains constant. This is the 3D interpretation. This is how it looks in 3D. Okay, so what do we have? We have the value of the third dimension constant along the level curve. When you were taught this, the third dimension was utility, which was kept constant along an indifference curve. Got it? Now, let's say, let me get rid of this one, this blade at z is equal to, and let me say this was z is equal to c1, z is equal to c1. Okay, let this be. Let's have this blade cut this above the previous one. Now it's cutting this here, and this is equal to, z is equal to c2 greater than c1. Okay. Now it's a paraboloid, so the image of this here is going to be like this. Along this level curve, the value of z is increasing. Okay, here it's going to be like this. We're going to take, if we take the region where marginal utilities are positive, then along this one z is equal to c2, along this one it was c1. We have an indifference map. Indifference map is just a map of level curves. Okay, this was cutting here, so it's a little offline, but now you get the message.